Okay, guys, let's get this last problem done. We realize that this is going to be our, what Miss Bennett likes to call bottoms up factoring. And this is when we see a leading coefficient that is not 1 in front of our trinomial. We want to move it to the back, okay? So I call this the bottoms up factoring. We're going to move it to the back by multiplication, right? And so we would end up with an x to the 4th minus 11x squared plus 30. All right, so we move that leading coefficient to the back. Now we're going to factor it just like product sum. So I'm thinking of two numbers that multiply to a 30 and it adds to a negative 11. I know both my numbers have to be negative, right? And I know my x's, because we're doing this quad form, my x's are going to be x squared. So I got 2x squared in the parentheses. And then I got to think of my two numbers. Okay, so my two numbers that multiply to 30 add to a negative 11, I'm only thinking 5 and 6, right? 5 and 6 multiply to a positive 30, add to a negative 11. All right, guys, now I'm not done with the bottoms up factoring because I moved this 3 to the back, right? So now I have to recognize that I moved it by multiplication, so I have to undo it. And that I'm going to do with division. I'm going to now divide out both those two numbers that gave me the 30 from me moving the 3 by the multiplication. So you're just doing an undoing of that. So I divide out those two numbers, and what's in the bottom of the fraction that I can't simplify, I move up. Okay, so that's why Miss Bennett called it bottoms up. So I know one of my factors is going to be a 3x squared minus 5. The other factor, I can simplify that. Negative 6 over 3, I can simplify that as 2. So this is a x squared minus 2. All right, so my factor is 3x squared minus 5 times x squared minus 2. Quad form. Quad form is just like product sum, except when we factor, we're going to have an x squared. All right, guys, last form of factoring, and this one is by far the easiest. This is the sum and difference, but not of squares. This is the sum and difference of cubes. You are going to attack it no different than the sum of squares. All right, so remember we would have a binomial, right? So we had two terms, but they were perfect squares. This time we're going to have two terms, but they are perfect cubes. And our goal is to find out what the cubed root of each term is. Once we find out what the cubed root of each term is, depending on if we're adding the cubes or subtracting the cubes, that's going to be our expansion. And guys, it's just point blank period going to be just like this. There's nothing we can do. So our expansion, if we're doing a sum of two perfect cubes, is going to look like this. We're going to find the cube roots. The first part of that expansion is going to be adding the cube roots. Then we're going to take the square of the first term cubed, and then we're going to multiply both of the cubes, and then we're going to take the square of the last term cubed. Now, if you notice this pattern here, it goes a and b in the first term, okay, or the cubed roots in the first group. And then we take a squared, and in the back, we take a b squared, okay? And then in the middle, we just multiply a and b together. Now, when we're adding two perfect cubes. In the expansion, we're going to do a plus, minus, plus. So if you see that pattern, that's going to be an easy way to remember it. When you're subtracting two perfect cubes, right? In the expansion, you'll still have the same thing, that AB, A squared, and in the back of B squared, and then AB sandwiched together, right? This time, though, you'll have a minus in the first part of your expansion, and then the next set is going to be all plus signs, okay? So that's how we'll expand it out. Now let's put this to practice. Again, this is the easiest thing that you're going to do. Here we go. So the first one, I'm going to decide, am I doing sum of cube or difference? Well, I am adding two perfect cubes, so this is going to be the sum of cubes. All right, which means that I'm looking at this expansion here. So I am going to end up with A plus B times A squared minus minus AB plus B squared. Okay, now how I find out what A and B is, I'm going to do like I did with difference of squares. I'm going to think to myself, for this first term, what variable did I raise to the third power to get x cubed? Well, obviously I raised x to the third power to get x cubed, right? So I know my A is x. The next term, I'm going to just ask myself the same thing. Well, what number did I raise to the third power to get 8? Well, the only number I raised to the third power to get 8 was a 2. So I know the cubed root of 8 is a 2. I'm just cube rooting those two terms and figuring out what the cubed root is. So my B has to be 2. Now I just plug in x for A and 2 for B. So this reads x plus 2, which is my B, times x squared minus, and I can have a x times 2, but I'm just going to put that in the front. It would be minus 2x plus B squared, which is 2 squared. Well, 2 squared is just 4. All right, so here is my expansion. Now let me try that again. I'm going to go to problem B. And I know this is another sum of cubes. And I just asked myself, what number or what variable did I raise to the third power? Or what's the cubed root of x cubed? Well, I know the cubed root of x cubed is 8. Or I mean, it's x, sorry. Is x. So this would be x cubed. Now I'm going to look at the 27 and I think, what number raised to the third power would get me 27, or what is the cubed root of 27? Well, the number that I would raise to the third power to give me 27 is 3, right? 3 times 3 is 9, times another 3 is 27. So now I know my A is x and my B is 3. I use the same expansion, which I know is going to be A and a B. And this is another way you can remember it, and you can know that, hey, I got an A squared and a B squared, and then I got an AB sandwiched together, and then I just do a plus, minus, plus. Now I'm going to plug in my numbers. Here we go. So for A, I know A is x, so I got an x plus B is 3. So x plus 3. And then I have a x squared minus 3x plus 3 squared. 3 squared, which is 9. So I have an x squared, or an x plus 3 times x squared minus 3x plus 9. All right, guys, let's look at the last one. All right, guys, so let's do the next one together. All right, so I know the cubed root of x cubed is going to be ax, right? So I'm going to just put parentheses around it. Minus the cubed root of 64 is going to be a 4, right? So I'm going to put that cubed around it. So now what we're going to do, we know it's the same pattern here, but this time instead of sum of squares, I'm using difference of, difference of cubes, right? So this time I'm using difference of cubes, which means I still have this same little a, b times my a squared, and then b squared in the back, and then a squared, ab in the middle, right? Except the signs are different. I'm going to start with a minus, and then I would have a plus plus, okay? So my a is going to be x. My b is 4, so I have x minus 4 times x squared plus 4x plus 16. Notice it's exactly the same. Okay, it's exactly the same as sum of cubes, except we're using different signs, right? Okay, let's try this D together. So D, if we look at this, 125, all right? So I'm asking myself, what number do I cube to get 125x cubed? Well, not only do I have an x that I cube, but now to get 125, I would have a 5. So this would be a 5x that I have cubed, right? That's the cubed root of that term. And the other term is the cubed root of 8, we know is 2 from the other problem. So this time, again, we're doing difference of cubes. And if we do our problem, our expansion, we know I got a, b, right? And then I'll have an a squared, a b squared, and then I would have an a times a b. All right. And I know since I'm doing difference of cubes, this is going to be minus, plus, and plus. So let's plug in. A is going to be 5x. B is 2, so this will be minus 2. A squared is going to be 5x squared times AB, so that would be plus a 2 times 5x, and then plus b squared, which I know that in my head, that's just going to be a 4. Now simplify all of this. This is going to be 5x minus 2 times, and remember our rule, our exponent rule. So this would be a 25x squared plus 10x plus 4. Okay, guys, I want you to take a moment and I want you to try this problem by yourself. Go ahead and pause the video. All right, guys, if you got the expansion below, you are on your way. The key to this was remembering to take the GCF first of 2. Now go ahead and look this over. You're going to do a couple practice problems, and then we are going to do some more practice on the methods of factoring in class. I'll see you tomorrow, guys.